All right, so this is a very short tutorial, however, it's still very important. Dividing a segment based off of ratio. So this has to do with fractions, a lot of fractions. So whenever you hear that term ratio, that usually means you're doing some type of fraction. So our goal in this lesson will be we need to find the point on a directed segment. So basically, by directed line segment, it means like line segments are something we've done before. Just a little line that has a starting and stopping point. Directed means a specific line segment between 2 points and their partition. So basically, it's saying we have these 2 points and there's another point kind of cutting it into another piece. That's what this objective means. So let's get into this. All right. So the introduction. So let's say um, this cartographer, this person making this map, is like, oh, we need to find where this post office is, and it's three to four. So we know that this post office from the school is probably like three, and then if you stop there, it's another four. So you can see that as kind of like, let's pretend that they're miles. It could be any type of measurement, but I'm just going to call it miles. So it's 3 miles from the school and 4 miles to the town hall. We don't know where it is, so we need to give a ratio of that. So that's our ratio to help us determine it. So let's say that's going to be 7 parts. So we're saying that if it's right in the middle, if it's a straight line and it's right in the middle, there's 7 parts. So we're going to figure out how much is it from the post office to town hall, or the post office to the school. What's the fraction there? So obviously it's going to be 3 of those 7 from the school, and 4 of those 7 are going to town hall. So we're going to learn about how we're able to divide these and how we figure that out. So this one, you can kind of see what we're going to get into. So what we're doing here is essentially we're going to add some of these together. So we're going to talk about the ratios and all that. So let's get into it. So the easiest way to do it is to label the distance from one area to the other. So if I want to figure out the length of AC, I'm going to call this length here A. So I'm just going to call AC as A. I'm going to call CB. I'm going to call that B. And in order to do that, I'm just going to do the first amount, this AC, over AC plus CB. So that's this little A plus over A plus B. So that's how we figured that out. And so AB. So in other words, AC is equal to this fraction times the whole. So let me kind of get a pen here. So we're going to do this part over the whole thing, over this whole thing is what AC equals. So AC is a fraction. In this case, the case that we just saw, AC is 3/7 of AB. If we're using the numbers from before, remember in this case, we don't know those numbers. So we're using just regular fractions. We're doing this A over A plus B. And that's how we figure this out. So that's a way of dividing up a line segment to try to figure it out. I just realized I could have erased everything. So going on to the next one. And then this allows us to basically measure it out. So let's take it one step further. If we're saying that the y is the same, we're only really dealing with the x's and b's. So instead of just calling it AB, we're going to call it for what it is. We're going to call it A minus B. So if we want to find this point C somewhere in here, we're going to say that point C, we're going to say that this length right here that we used before, this length is the x value of C minus the length value of the x value of a, sorry. So this, so if I said this was like 10 and this was 6, then this right here had to be 4. That's all we're saying. So instead of writing it as AC equals this right here, this ratio, we're going to say it's x, the x value of b minus the x value of a. And instead of saying AC, we're going to replace that by saying x of c minus x of a. And since we want to find the point where c is, we're just going to say x of c. We're going to add x of a to both sides. So we're going to do x of c. So this is that a that we're adding. So we have x of c equals, now that we move that over, this x of a. That's why we're adding these over here. So that's where we're going to do it. And then if we look at the next line, we're going to replace more of it. So actually, we didn't. They're just explaining it further. So that's all they're doing here. Oh, they just explained what I literally explained earlier. They're saying AC is equal to x of a plus that. So that's another interesting way of looking at this. But mainly you can kind of see where we're using this. If something is halfway through, if something's a different fraction, this is a good tool to use when you're drawing this out. So let's kind of look at this. So we're going to do this activity line in a given ratio. So I'm going to do that. And we're looking at this. Okay, so we have this, our A and our B. They're always set in their place. We can lock them, we can unlock it. So I'm not going to unlock that yet. Let's kind of take a look at this. All right, so any line is not horizontal or vertical can be represented as the hypotenuse. So just saying any line that's at an angle can be represented as the hypotenuse. All right, that's cool. X-intercept and y-axis is in GeoGebra AB, so we already have that, such that a right angle. So it's just saying that we have this right angle here. 2/3. You divide AB into 2/3 using the ideas from what we just learned. Find and record the horizontal sides. Find and record the x coordinate of the point 2/3 of the way, and then we're going to find and record the vertical. So we're going to do two things. We're going to figure out, where's my pen? There it is. We're going to figure out the horizontal, figure out what the length is, and then we want to figure out the x value when we cut it by, what is that? 2/3. So this has to be 2/3 of that. And then from there, we're going to do the vertical. So the vertical is going to be this one. And we're also going to cut that into 2/3. And we're going to see where we can do this. I'm going to make it where the 2 comes first. All right, so 2/3. Write down the y coordinate. This point of AB should be a ratio of 2/3. Okay, so after we do that, after we figure out the x value and the y value, we're going to kind of like do this. And that should be our point right here. And I'm going to do that by doing a horizontal line and a vertical line just to super illustrate it better. But in the meantime, let's get through all this. So the first thing we have to do is we have to figure out this x value, this x value, this point right here. So I'm going to click this point, and I see here that it is 5,1. And that makes sense because we're going to leave this here. Our y value is the same, so that's 5,1. I don't know why it's not labeled. I'm going to label it right now so we can see it. They probably didn't want us to see it, but I want to see it. To show trace. That doesn't do it. Okay, I guess we can't label it. Well, just remember it's 5, 1. That makes sense because this is 5. Our y value stays the same. So this right here has to be 5, 1. So I'm going to go ahead and write that in myself. So our y value is 5. And our x value, or I'm sorry, our x value is 5. Oh my gosh, I got that backwards. I'm so sorry. Our x value is 5. And our y value is 1. All right. Okay. So that tells me, give me a second here. So that tells me that in here, oh my gosh, that this entire length is 4. All right. Not ideal because obviously we would want it to be 5. That way we could go like, oh, two-thirds there and 2/3 here. But because it's 5 take away 1, we know it's 4. So we need to figure out what 2/3 of 4 is. So consider the coordinate. We want the ratio to be 2/3. Okay. Write down the coordinates. Okay, so they want it 2 and 3. So they want us to divide this into essentially 5 pieces. So they want it to be divided into 5 pieces, right? And we want it 2/3 of the way there, right? So we're going to do 2/3. So this is 2 over 5. And we want to multiply this by 4, right? And we have to add that to whatever value we have here. That was our formula from before, x of a plus our fraction, right? And then we're going to multiply that by the total length. So in this case, that was our x of c minus x of a. So that's what I did here. This is my x of c minus x of a. And I'm going to do my x of a. So I'm going to have to add 1 to whatever I get. So let me start showing my work over here, actually. So first things first, I have to say what my x of c is. So I'm going to use my equation editor here. Uh, uh, so let's record the things here. Oh, and they were actually nice enough. They put the formulas there for us. So I think I was just ignoring it because it looked complicated, but I'm just going to write them in. So then x sub a, you can do control down is what I usually do here. X sub a, I'm going to add that to our fraction. If you use their parentheses, it actually does get bigger when you do this. I didn't know that. A student told me this. We're going to do this. And then we're going to do the fraction x sub b sub b minus x sub a. And the beauty of this formula is that you don't necessarily have to have them in horizontal lines. The way I did it, they were in horizontal lines, so it was a little different. All right, so looking at this, what we can do is I am going to plug in my x of c, or not plug in because I don't know what it is. So we leave x of c the same because we do not know that information. Our x of a is this point, our 1, our x value of that point, plus the first part of our thing. In this case, oops, I need to use their parentheses. I just said that. Fraction. The first part is 2, and then we have 2 plus 3, 3. And my num locks on. Definitely my num locks on. 3. And then our b, x of b, So this is our point B. X of B is 5, take away the 1 in our next line. I'm lazy, so I tend to do this. Control V equals 1 plus our fraction 2 fifths, 5, and then we end up getting x of c. Where's my sub c? I could have just copied it, I just realized. Equals 1 plus the fraction 10 over, oh, I'm sorry, this was supposed to be a 4. I was like, wait, that's perfect. 8 fifths. So considering that another way of saying 1, I had that copied, so I just pasted it. 1 is 5 over 5 plus, and the reason why I'm doing this is so the denominator is the same. 5 divided by 5 is 1. I'm going to do 8 over 5. That tells me that my x of c, well, I could have just pasted it. X of c equals 13 over 5. Over 5. All right, and that's my work for my x of c. Now I want to do my y of c. So I'm going to do the exact same thing, except I'm just going to change the values. So me being creative is if I have to do basically the same thing, I'm just going to copy all the work. However, I need to do it for my y values. So the numbers are all going to be different. The variables are going to be different as well. So that's a y. A y. And I think this is a lowercase c, so I've been using the wrong variable there. That's the same. This is the same, except these are y's now. Y's now. This is going to change to y. This is going to change to y. This is going to change to y. You guys kind of get the idea, but I have to still get through it. It's still, I think it's still less work, or at least it makes me feel like it's less work. And in the end, that's what's important. So what's the y value of our x of a? The y value of our x of a is also 1. Let me use a different color for this. So go here. This right here is my x of a. Y of a. Y of a. Oh my gosh. And this right here is our y of b. So this method's actually kind of nice because it doesn't really acknowledge that this is a thing. It's just kind of saying like it's there, but you don't need it because you can just plug it into this formula. And if you don't know this formula, like I said, all you're doing is figuring out how long this is, and then you're figuring out how long the other one is. I'm going to do it in blue. We solved it in blue. All right, so that's my x of a. That's my x of b. My first part does not change, so my little a doesn't change and my little b doesn't change. So this part's still the same. This is the same, however, now I have to look at my y value. My y value is 3. So my y of b does change. So I'm going to change that to be a 3. Going down here, this becomes a 2. This stays the same. 2 times 2 fifths, that's going to be 4 fifths. This is still 4 fifths. Because our denominator is still 5, we're still going to leave it as 5 over 5. So, again, we're saving some time there. I might not be because I'm explaining it, but there you go. And then here I'm going to do 9 fifths. And that's how you show your work. So let's see where this point would lie. So I said I was going to show you a vertical line and a horizontal line to kind of show you what this represents. So what I'm going to do here is I am going to make a line here. Oh, I don't think you guys are going to be able to see it because of this. Oh no, how do I get? Let me hide my tools for right now. Oh, I'm worried I might not have them back. So I'm going to make a line that x equals x equals 13 over 5. Oh no. I'm going to do x equals 13 divided by 5. So I have my line there. And then my other line is going to be y equals 9 over 5. So I'm just going to say y equals 9 over 5. And then that point right there, the point where these two intersect, I'll intersect them right now. Use the line of intersection. Boop, boop. That's my point. Let's say I don't want to see these lines anymore. I can go up to lines. Where are my lines? Lines. There's segment. I don't know how to hide my lines. Oh, there we go. These lines right here. I'm going to hide them. So settings, hide object. Go to this one, settings, settings. Oh, I have to exit this first. Settings, hide that object. But my point of intersection should still show. So there's my point. That's going to be my point right there. So write the equation of the slope intercept point that lines by substituting the points in the coordinates. Show your work. Write an equation for AB in slope intercept form, then check if line C. Okay, so I need to find a formula for this, right? So I'm going to use point slope form to solve this. All right, so point slope form. Grab this. If you don't remember point slope form, that's y minus y1. That just means any y. In this case, I'm just going to use y of a. The regular slope form is this. Over x minus x2. Now, one thing that you're going to need here is the slope. So we don't know what the slope is. So we have to do that as rise over run, also known as y2 minus y1 over x2 minus x1. Now, for in this case, since we're using different points, I'm going to call my first point is my x of b. So my y of 1 is going to be my y of b. My this one right here, oh, this is supposed to be a 1. I'm going to change that to b, a. Oh my gosh. Going to change that to a because it's x1. So this one, since it's my b, this is, or since it's my 2, it's my b. Since it's my 2, it's my b. Since this is my 1, I'm going to call it my a. Since it's my 1, I'm going to call it my a. Just to kind of make this a little bit better. So let me show my work on all this. Oh no, I can only do it with my pen. So let's show my work. So there's going to be a little tricky here. There's a lot of work in this one, unfortunately. So we're going to say y sub y minus y sub a equals my m, but instead of m, I'm just going to use this formula. So let me put in parentheses to show I'm doing work. I'm going to do y sub b. You guys don't have to make it capital. I'm just in the habit at this point. Y sub a. Oh, this is already a sub. I don't like that. What is happening here? Okay. I don't know what happened there. Y sub b minus y sub A over. I'm just going to copy and paste this because apparently I struggled with that. I'm going to change this y to an x, this y to an x as well. Okay. And then that's going to be multiplied by just a regular x minus x sub a. It's a lot of work, but I'm basically saying I'm picking a point, and I chose to pick this point. That's all I'm doing. And then this is our slope. All I'm doing here, I don't like using the formulas, but since this is a lesson based off formula, it's doing my rise over run. So this is my rise over run. So that's how come I'm taking 5 minus 1 to do my rise. And I'm doing my, oh, I'm sorry, 3 minus 1, because this is a 3. 3 minus 1, so this is going to be a 2 for my rise. I'm going to do 5 minus 1, so that's 4 for my run. That's all I'm doing. So this looks intimidating, but it's not. So then I'm going to do y minus my y value for my a, which is 1, equals, I'm going to do my parentheses. I'm just going to copy this, to be honest. I want it to be their parentheses, not the keyboard's parentheses. All right. So my YB, that I said was 5. This I'm going to say is 1 because it's my Y of 1. This one is 3. And this is 1. I'm going to do a parentheses. That's going to be x minus 1 because my x of a is 1. Remember, this is your A, this is your B. The sub just means where is that letter coming from. So where's this y value coming from? From my point A. Where's this y value coming from? From my point B. Where's this x value coming from? From my point B. That's all that's happening. So let's get down to this. So my formula will end up being, and does it say y-intercept form? Please don't say it. It says y-intercept form. And it does say a slope intercept form. It does say that. It's a point slope form. They just wanted to make this difficult. All right, so that's going to be, let me use their parentheses, not their absolute value, no. Their parentheses, their fractions. So that's going to be 4 over 2, which is just going to end up being 2, luckily. Minus 1. This becomes y minus 1. I'm going to do parentheses. Actually, I don't need to do parentheses. I'm solving that, solving the parentheses. Minus 1. Now I'm going to distribute this 2. So I get y minus 1 equals 2x minus 1 minus 2. I'm distributing. 2 times x is 2. 2 times negative 1 is negative x. And then I need to add 1 to both sides. So I get 1 equals 2x minus, so add it. I'm adding 1 minus 1. And this should stretch out if you need more space. So now they want us to test to see if this works. So basically what they're saying is plug in your point C into here and see if it works. So if I did this formula correctly, it should work. So I'm going to insert an equation. My first equation is y equals 2x minus 1. Now I'm going to plug in my y. My y said was 9/5. So 9/5, I'm going to do this. I'm going to 9/5 equals 2 let me use their parentheses because I'm going to have to use a fraction in here. Their x value is 13 over 5. So 13 divided by 5 minus 1. So I'm going to have to multiply. When you're multiplying, remember, this is a 2 over 1, so you don't multiply the 5 by 2. You're only multiplying the numerator, 13th. So I'm basically going to copy this. You don't have to copy it if you're comfortable with typing. I'm just lazy. I'm going to delete this and delete the parentheses. This is 26 over 5, meaning that when I subtract this, I'm going to convert this to have the same denominator. So I have another fraction that is 5 over 5. Let me double check anything because I feel like this is not satisfying the point, and it doesn't. Give me a second, guys. So I just realized something. The slope is off. I did this wrong. I plugged in the wrong y value and the wrong x value. Let me get back to the slope. So I was looking at that. I'm like, this should work. And the reason why it doesn't is I put the x value or the y values on top instead of on the bottom. So the only thing this really does is just change our slope to be 1/2 rather than 2. So this changes the slope to be 1/2, which I say only, but that's actually a pretty big deal. So let me go back and fix this. So that means this is 1/2, meaning that this is also 1/2. And when I add that, what ends up happening here is we get this. This becomes a positive 1/2. So what's happening here is because I accidentally did it as xa minus or xb minus xa, our slope was flipped upside down, which is totally wrong. And you can see that that ruins everything else. You saw that when I was doing it, it was going to say something like um, 9/5 equals 21/5, and that obviously isn't true. So that's why I knew something was up. This is why they have you plug in your point just to make sure. So that's if you're ever wondering why they ask you to check your work, that is why. I accidentally flipped my slope over and it created a completely different problem than I should have been doing. So let's go back to fix it. So change this to 1 over 2. Change that to plus 1/2. And it even made my intercept completely wrong because I was saying that my intercept was negative, which would have been down here, but clearly it's like going to be right here. So I would have found that out once I tested the line because I would have tested it in here. If you ever want to double check it on GeoGebra, it's actually not that hard to check it on GeoGebra. Y equals 1/2 of the same thing as 0.5, 0.5 x plus 0.5. You can see it lines up perfectly. So no mistake on this one. I verified by using GeoGebra. Um, our x is still the same, however, our slope is not. So we're going to change that to 1 over 2. Unlike the other one, this does have a denominator to multiply by. So this is 13 over 10. This is 1/2, so plus fraction 1, 2. We're going to change that since this is clearly going to be a 10. We're going to change this to my fraction 5 over 10. We're multiplying the denominator by 5 to make these the same. And 13, 10. So we end up getting this 9 over 5 equals, and it's going to look weird, 18 over 10. But as we know, 18 over 10 can be divided by 2 on the numerator and the denominator, so that turns into that. So this is good to go. So we can edit that in. You can see after you submit it, They're using fractions. I probably should have done that, to be honest. Um, Probably would have been a lot easier. I'm sorry about that. So they you can see how they're doing it with fractions, but now you know how to do it with or do it with decimals. But now you know how to do it with fractions, so that's a little bit easier. Now verify that it divides it by using the distance formula. So we want to use the distance formula. If you don't remember the distance formula, I always say it's the Pythagorean theorem. So it's a squared plus b squared equals c squared. We're going to call it d squared for the distance squared, which means that the distance equals the square root of a squared plus b squared. And our a is really our x of b minus x of a squared. And our b is going to be our y of b minus y of a squared. So let me write that formula in real quick. Well, not real quick. So we're going to say distance equals the square root of. You guys don't have to write the formulas. I do it for due diligence. I should have mentioned that in the last one. Hopefully, not mad at me. A squared, so this is our little a squared. Then we're going to do b squared, so that's going to y, control, sub b, superscript. Oh my gosh, yeah, don't do these if you don't want to. It's just going to be a lot of work for you guys to keep all of your square roots, all your subscripts and your superscripts correct. So when you enter this into the distance formula, this is what you guys do have to write though. You're going to write it as 3 minus 1 squared plus, what was it? 5 minus 1 squared. So this is d equals square root. Another thing you guys can do too is you can also do this on paper and take a picture of it if that's an option for you. You can just take it with a cell phone or something. 4 squared. So, and this ends up being d equals. We're just going to leave it like this. Um, and you'll see how we do this after. So we need to find the distance of that first. So this is 4 plus 16. So distance equals square root of 20. And we're going to leave it like that for now. So we're going to do 2/3 times the square root of 20. So 2/3 times the square root of 20. So I'll just leave this in parentheses here. We don't need to do anything fancy with it. But if we do want to do something fancy with it, give me a second. It would be the same thing as saying, um, uh, well, we will do something fancy with it. It's not too fancy, I promise. What we're doing here is we're splitting this up into 4 and 5. Guess what? You can take the square root of 4. You can't take the square root of 5, but that's the only thing we're doing here. So this becomes 2 times 2 times square root of 5 over 3. So this ends up being, it was just bothering me. I want to be lenient on you guys, but mathematically, it's very weird to see something that can be reduced. So that's why I'm reducing it for you. So that ends up being 2/3 of the distance. We're taking 2/3 of that. So in order to see if it really is 2/3, what we're going to do is we're going to find the distance from our point G here and do the same thing, except now it's going to be for x of c. So this is going to be a little bit of work, but I trust you guys can handle it. Of course, it's only going to copy that. Let me see if I can get the actual picture. I don't want to copy the whole thing, but I will if I have to. Okay, so whenever you see these little dots, that means you got it. So Control C. Here, gonna go Control V. Control. Oh, you have to go into here to copy it. I forgot about that part. And honestly, we're not going to keep much of this, to be honest, because these are the C's that we're keeping. This is going to be a C. So our X value of our point C is. Where's our X value of our point C? It's like way over here. 13 over 5. So this is a fraction. 13 over 5. This is what I meant by using their parentheses. If you don't use their parentheses, they don't stretch out with it. I'm going to delete my parentheses. Okay. I'm pretty sure if I uppercase it from here, it should work. Control up. Yeah. There we go. Downside to writing your own parentheses in Edmentum is this won't end up working. Now I need to find my y value. So my y value was 9 over 5. So this ends up being a fraction. Fraction 9 over 5 minus the 1. And I realize this is a lot of work. I'm sorry. For that. Okay. So let me erase everything else because all of this is useless at this point. All right. So we're going to copy the same thing so we don't have to rewrite it. So highlight all of it and then Control C. Control V. This becomes 5 over 5. And this is also going to become 5 over 5. This makes it easier to subtract. So that becomes 8 over 5. This 13, take away 5 is 8. And then we're going to do 5, so this becomes 4 over 5 because we subtracted it out. And then, ooh, I actually want to copy this one, so it's a lot less. We're going to essentially get rid of these squareds. So 18 times 18. 18 times 18 is 64. 5 times 5 is 25. Whenever we're squaring, remember we have to distribute. So this is 16. This is 25 also. And we're doing that, getting rid of this. Enter. So now if we add those two together, we actually don't need the parentheses anymore. I don't know why I left them. After you square it, you kind of don't need those parentheses. There we go. You might want to leave them because what I had to do was I had to delete, and then it's like, do you want to delete this? And then I had to hit delete again. That might be a little too tricky, so don't do that. I don't want you deleting your work. If we add these two together, 6 plus 4 is 10, so that makes this 60, 70, and so we get 80. So we're going to get a fraction of 80 over 25. If we take the square root of 80, what we notice is this becomes 4 times 20. We can take the square root of 4. Can't really take the square root of 20, but we can break it down into 4 and 5. So what happens here is we have 2 times 2 on the top. That might sound familiar. You can take the square root of 25, so that makes this easier. When we do the distance, we end up getting um, 2 times 2 times the square root of 5. This should be where you should start seeing the similarity over 5. And that becomes fraction 4 square root of 5 over 5. So this is why I had to simplify it when I did it over here. And as you can see, doing the distance formula with fractions is a lot longer. Um, Once we do all that, we see that they are the same. So we have confirmed it. They use decimals again. Use their decimals. Be smarter than me. Um, yeah, I'm pretty sure even if I submit this one, they're using decimals. So use their decimals. Decimals are easier. Plot point C to verify the coordinates. Also verify the distance calculated using GeoGebra. Take a screenshot. Okay, luckily for me, I already did that. I did the hard way though, instead of plotting the point. So you can see the point there. All right, going on from here, we want to find the distance. So we're going to take a distance, measuring tools, distance. So we're going to do this to this. They give you a decimal. This to this. They give you the decimal. If we take 2/3 of it, it should work. So I'm just going to export image, download, save it. I'm going to insert image, choose a file, and this is the one from today. Wait for it to do it. And when I do the distance, I'm going to want to do the distance here. So I'm going to verify that by simply doing, give me a second here. 2/3 of distance. 4.47 over. The reason why I do 2/3, by the way, in case you guys are wondering, it's like, why is he doing it this hard way? Is because you can't 100% get 2/3 as a normal decimal. Like, if you did do 2/3, 2 divided by 3, it goes on forever. So that's how come I prefer fractions. They're more accurate. But I understand I probably lost you guys through this way. So I have this. So, did I plug in the right thing? 4.3, 2/3. All right, something's up here. GE. What's E? Where's point G? Where's point E? Okay, so point E is there. I don't know why they're calling it point E. That's a little strange. It still works though. Okay, so that E to F. I'm not sure why I'm not getting the right answer here. So 2/3. So 4.4 divided by 3 times 2. We verified it using math, and that's all that matters. Is this point correct? I think what's happening is there's a lot of round off error going on here, so we're just going to leave the picture as evidence. I can't even begin to figure out what's going on there, but we can do that part. Next, reopen the line segment ratio. Then we're going to find another difference. So give me a second here. All right, so let's reopen it. So I'm going to delete this. I'm going to reopen this. I'm going to try to use decimals now. I'm sorry. I probably lost a lot of you. So move the points and the locations. And then we want to use the 2/3 ratio rule. We're going to follow the exact same steps. To be honest, using the distance formula is really tricky. So what I'm gonna want you guys to do is I want you to just use this formula, and that's about it. So I'll do this, but I'll do it with different formulas and try to make it a little bit easier. So one thing that I want you to think about when you're doing this is I want this to be 5, so it's a little easier to divide up. And then I'm going to want, let's make this, actually, let's make this 10. We're going to make this a really easy problem to do. We're going to make this 10, and we're going to want to make this 5. So if we want to make this 10, we're going to want our B. So I'm going to unlock it, but I'm going to make this a little easier to do. So I'm going to change this. We're going to add 10 to our x value, so that's going to be 11. So our point, instead of being 5, 3, we're going to make this 10. And if we add 5, we're going to make that. All right, cool. So we do that, enter it in. And let me zoom out so we have a better look at it. So all of this should end up being a lot easier now. So I just did that to manipulate it better. So what I'm going to do here is now I'm going to say that I'm still going to use the same formula. Don't get me wrong. So I'm going to do this. I'm going to do this as x sub c equals. We want to make this 2/3. So it's our x1 is still 1. So I'm in the sub. Sorry. Sub c equals 1 plus the 2/5 that we had before. Oops. I'm just going to honestly leave it like this. They made it a little too long. And then we want our uh, thing. So that was 10. So our x value is 10. So when we do this, we're going to say that x sub c equals 2/3. So 2 times 10 is 20. So we're going to do 2 plus 20 over 5. This makes it easy because the reason why I wanted you to make it divisible by 5 is, guess what? Now when you do these 2/5, it's nice and simple. So now we get 1 plus 4. So we get x of sub c equals 5, right? So we're going to put that in there. Next, we're going to use the next formula, except this time, like I said, it's going to be easier. So y sub c, our x of 1 is still 1, plus our 2/3, that's still the same, times, this time it's 5. So this part right here is 5, so that's why I'm putting in the 5. I know I'm going fast, but I know it's because I spent so much time. I just want to uh, give you guys the process faster. If you need help, uh, don't be afraid to leave a comment. All right, so when we do this, we're going to do 1, and then plus 10 over 3. Oh, this isn't as nice as I wanted it to be. Should have made it 6. You know what? I can still change that. I'm going to change this to 6. Oh, wait. No, it's divided by 5. What am I doing? Victor, come on. It's like, I know it picked those numbers right for a reason. There we go. And then this becomes y sub c equals 1 plus 2. So we get our y sub c equals 3. Cool. So that's my x, that's my y. Let's figure out our slope. And our slope did change. So we're going to do our slope. So our slope is our rise over run, which we've already kind of done. So if I do my slope, I'm going to say m equals, do my fraction. I'm going to do 5 minus 1. So do 5 minus 1 over my, where it's my 10 minus 1. So my slope equals 4 over 9, which I learned from my last encounter with this. They want it in decimal form. 4.44. I'm just going to use 2 decimal places just to make it simple. 44. So when I put this in, I'm going to put it in as y minus 1 equals 0.44 x minus 1. So the next line is y minus 1 equals 0.44x minus 0.44. Add 1 to both sides. So this would be y. We're adding 1 to both sides. So I know I'm going fast. I'm sorry. Equals 0.44. You can't add 1 to an x, but you can add it over here. So negative 0.44 plus 1 equals positive 56. So we get this, and then we want to verify that this is true. So from here, I think you've shown enough work. I don't think anyone would argue that you need to repeat all the steps to understand it. You can see all of this happening. So on this one, you're just going to say it was a lot of work. At least that's what I think. So put in whatever you think it is. I'm going to give myself a 4. I'm going to say it's because I didn't use decibels, and that would have made everything like 10 times easier. All right, so moving on. Hopefully, the next isn't too bad. I was like, well, this isn't too bad. It's only 16 slides. So here's our formula here. So this is just an interesting way of solving it. They're doing something interesting here that involves a y-intercept. I think this looks way too complicated of a formula. This looks nicer. It's like your part over your whole. So basically, this is the ratio part. I didn't go over that before, but this is your ratio part. So if you have 2/3, the 2 goes on the top, and the 2 plus 3 goes on the bottom. We went over it, but I didn't explicitly say it. So I'm saying it now. All right, and that's how we would solve for this. So, and it works for negatives and positives. I think that's what it's saying here. So let's get into the next one. All right, so this is a useful tool to divide up line segments in any ways that we want to do it. So let's practice this in real life. Or let's practice this going here. Why is this not deleting this? Oh, different tool. This is my annotate tool. All right, so now we're going to try to answer this question that involves dividing into equal parts. So one thing that you'll notice here is they have these divided up, and we're going to try, they have the horizontal line segment. So by doing the horizontal line segment, we're able to divide them up nicely horizontally. So use your knowledge of similar triangles to explain the construction of parts. So if we look at this similarly, we can say that A and B, so they share a side in common. Okay, so they're sharing a side in common. And also, let's see what they're doing here. Type your response and answer provided below. Let's take a look. Use your knowledge to explain why the construction divides the line segments into equal parts. So I'm going to assume that these two lines are parallel. So if these two lines are parallel, then they also share a similar angle. So we're going to expect that these two lines are parallel. This AC is parallel to DB. So um, assuming AC is parallel to BD, then the angle each line makes. So what I'm describing here, and you guys can do this in your own words, the angle that each line makes with AB, then the angle each line makes with AB is are congruent to each other. Are congruent because they're two separate lines and they're congruent. So I'm saying these two angles are congruent. They also share a side uh, AB or BA. So for this triangle, it's AB. For the other triangle, it's BA. And AC is equal to BD. So they are similar by side, angle, side. So this side, we're going to assume that this side is equal and that side is equal. Why does this work? So so why does this work? So the lines cutting the line segments are parallel as well. So the sides would fall under angle side angle similarity. And the reason why I'm saying that is this all of these angles would have to be the same. So that means it is cutting it down nicely. Similarity. So that's how I would describe it. I think that's what they want us to do, but that's the explanation. Is it's side angle side similarity. So they're already similar. So any theorem would work. Now, if these lines are parallel, then all of these should be congruent because they're all parallel. So if they're all parallel, then they should all be divided evenly because they're symmetry, meaning that the lines divide evenly due to their proportionality. So I'm saying that they're dividing evenly because their proportionality means that they all have the same ratio. And that's what we've been talking about is ratios. So I'm going to submit that. And the construction of series of triangles A, B, each triangle, the vertex off the other. I feel this is another good way of kind of describing it. I like using the side angle side and then the other way. I wish they would have given us more information because I had to assume that they were parallel, and they really should have described it more because here they're just kind of making stuff up, I feel like. All right, so now we have this, and we want to make the coordinates 2/3. All right, so we have to use our formula. One thing I forgot to mention for this one is if you guys are having trouble with this, um, there's always the midpoint for there's the guided notes. The guided notes should have the formula in here. Fill these out. So that's something that you can do while you're doing this. All right, so going on to this, I'm going to do this formula, which was AC equals XA, little a over A plus B. Oh, I forgot the plus sign here. Plus times whatever my AB is. So, and my AB, if you remember, was literally just x of B minus x of A. All right, so we have that. So let's take a look here. CB is that. So we're going to find this. Oh, and actually, unfortunately, what's happening here is we have to do this twice because the x's and y's aren't matching up. So I have to do this also for the y's. Now, this isn't too bad, but it is going to be some work. I'm not denying that. So let's get this down. So I'm going to first put in this. Oh, and luckily they did it nicely. They did the 10. What I'm hoping is once we figure out the A, since all the X's are different, we only have to do the first one. So we're only going to do that. So notice how all the X's are different. That's good for us because that means we only have to do the X's. So it's a little wrong on that. Take advantage of the fact that's multiple choice. So XC equals -5 plus 3 over 10. That's 3 plus 7 is 10. And then this is going to be our x, so it's -2 minus this, so that ends up being 3. So this becomes xc equals -5, 9 over 10. That can't be right. Our x is -2 minus -5. No, that's 3. That's the, and then our xa is -5. Well, I guess that's true. Oh, because it's negative. That's right. Okay. So this ends up being negative. So this is over 1. So -50 over 10 plus 9 over 10. This is a -41 over 10. If we divide that out, we find that that's -4.1. So that's how we get this one. So that's our answer there. And you can see my work here. You can always rewind if you need to do it again. All right, so going on to the next one. And then there's summary. So here's our formula. We can use the same formula to figure out why. I don't like the way this looks. If you like it, good on you. It is useful, I guess. If you know this, it's 2 blah blah. So actually, this might have been nicer to do. Let me see if I can do it for that last one we did. So our A was 3, or xb. Oh, this is a good formula to use. So you might want to use this for the test. This is actually pretty useful. All right, so hopefully that helps.